Hey guys, and welcome back to another video. Today we will be producing some acetic anhydride via the pyrolysis of acetone. As a quick side note, this reaction involves ketene gas, which is extremely toxic in concentrations as low as 100 parts per million. A proper sealed apparatus must be used to contain the ketene, and the reaction must be done outside or in a fume hood. Do not attempt this at home. To begin, an apparatus was set up with 400 milliliters of acetone in a 1 liter round bottom flask. On top of that, a 1 liter bulb was attached with a Claisen adapter on top. One arm of the Claisen adapter has a rubber stopper with 2 copper wires attached to a coil of nichrome wire entering the bulb. A high current power supply is also attached so that the wire glows red hot when the power is supplied. It is important to test that the wire glows red hot when it is not near the acetone, as an explosion will occur. The other arm of the Claisen adapter has a 300mm condenser column attached with a gas takeoff adapter. The gas takeoff adapter has a tube which bubbles into 205 grams of glacial acetic acid, which I demonstrated how to prepare in a previous video. The acetone can be purchased from hardware stores or distilled from nail polish remover. To start, the acetone can be brought to a reflux using the heating mantle we made in a previous video. It is important to ensure the acetone is fully refluxing and all the air has been displaced from the apparatus before turning on the nichrome wire, or an explosion will occur. Once refluxing for a few minutes, the power was turned on to the nichrome wire, which immediately began pyrolyzing the acetone to highly toxic ketene. The ketene form then begins bubbling into the glacial acetic acid and reacting to form acetic anhydride. An additional Erlenmeyer flask was added in between the vacuum takeoff adapter and the glacial acetic acid, so that if suckback occurs, our product won't enter the refluxing acetone. As a side note, I was wearing a respirator throughout this procedure. The glacial acetic acid turned black, which is likely just from side reactions producing contaminants which will be removed later. The acetone also turned blue, which was interesting. After reacting for several hours, the heating coil was turned off, the apparatus was allowed to cool, and then it was disassembled. The reaction mixture contains other contaminants along with the acetic anhydride product, so fractional distillation was performed to purify. First, some acetone came over around 55 to 62 degrees Celsius, then unreacted glacial acetic acid came over around 118 degrees Celsius. Finally, the acetic anhydride came over around 140 degrees Celsius. The acetic anhydride was having a challenging time climbing the fractional column, so the apparatus was cooled and a simple distillation was set up to remove the final acetic anhydride. After distilling, 35 milliliters of crystal clear acetic anhydride was obtained. 150 ml of glacial acetic acid was also recovered. This indicates that a lot more ketene still needed to react with the acetic acid. I learned afterwards that heating the glacial acetic acid to about 40 or 50 degrees Celsius will help the ketene dissolve into solution, so in the future that should be done. Anyhow, this 35 milliliters should be enough for the reactions that I want to do. I hope you guys enjoyed, and I'll see you in a future project. Okay, bye.